Hey everybody, Dr. Nelson here. This is a video that's going to introduce you to something called a quadratic function. So you're going to take some notes with me, and then you'll have a chance to try some problems on your own, and then at the end you can see how you did. Alright, so before we talk about just what exactly is a quadratic function, let's review two other types of functions that you've learned about this year while taking Algebra 1. So the first was a linear function, and linear functions have the format y equals mx plus b, where again m is the slope and the b is the y-intercept. So say if we're going to graph it, or graph a linear function, it could have a positive slope going upward, or it could have a negative slope going downward. And again, we could use the slope-intercept format to graph it, or we can simply make an xy table. So let's say we want to plug in the points for y equals 2x plus 1. So all you do is plug in points. So say if x is 0, y would be 1. If x is 1, y would be 3. If x is 2, y would be 5. If x is negative 1, y would be negative 1. And if x is negative 2, y would be negative 3. Alright, then you learned about something called an exponential function. And keywords like decay and growth are important terms when we talk about exponential functions. And remember, these have a different look to them. They're not linear. So again, let's say if we wanted to say come up with the coordinates of say y equals say 2 to the x power. Alright, so again, when x is 0, anything to the 0 power is 1. When x is 1, the y value would be 2. When x is 2, the y value would be 4. When the x value is negative 1, it would be a half. And then when the x value is negative 2, the y value would be 1/4. So if we're going to graph these points, we'd have 0 and 1, 1 and 2, and 2 and 4, and then negative 1 and a half, and then negative 2 and a fourth, like so on. So the rest of the graph will look kind of like this. Alright? So today you're going to learn about a third type of function, which is called the quadratic function. So if you turn the page, let's take a look at this. Alright, so now let's take a look at our third type of function, and this is called the quadratic function. And quadratic functions have several key characteristics that make them different than linear or exponential. And they have this format where it's y equals ax squared plus bx plus c. And the important thing is this x squared. This right here is what makes it quadratic. And when I say x squared, what shape do you hear me say? X squared, there's a square, right? And if you underline the prefix quad, right? A quadrangle has 4 sides, right? So anytime you see that x squared, that gives away that it's a quadratic function. So some examples of a quadratic function could be y equals x squared plus 4x plus 4. That's one example. Another example could be, say, y equals 2x squared plus 7x plus 3. Another example could be, say, negative 3x plus 2x plus 1. And then a final example could be, say, just y equals x squared, say, minus 4. Okay? So you don't necessarily have to have that bx value in the middle, okay? But you have to have an x squared somewhere in the function, or it's just not a quadratic function. So let's say if we want to graph a quadratic function, okay? Just like all the other functions you've been learning about, you can make an xy table. And there's actually other ways of doing this, but for this example, let's just come up with the input-output values for, say, the function y equals x squared plus x, and then how about plus 2? Alright, and the key thing about this is, please write down PEMDAS. You have to always follow the order of operations. Always, always, always when you do this. Okay, so here we have a squared, and we're adding the x, and then plus 2. So let's say if x is a 0, 0 squared is 0, plus another 0 is 0, plus 2 gives you a 2. Let's use, say, 1. 1 squared is 1. 1 plus another 1 is 2. Plus 2 is 4. Let's go with 2. 2 squared is 4, plus 2 is 6, plus 2 is 8. And let's go with a negative value. How about if x is -1? Well, -1 squared is 1, plus a -1 is 0, plus 2 is 2. And let's go with a -2 for x. -2 squared is 4, plus -2 is 2, and then plus another 2 is 4. All right. So we're not going to graph this, but quadratic functions have a different appearance than exponential or linear. Okay. They're going to look like this. If you copy this down, it basically looks like a U. It's called a parabola. And make sure you put arrows on both ends, because they keep on going forever in both directions, going up this way, and going up this way. And it can also go downward. So something kind of like this is also a quadratic function. And there it is. All right, so the big thing about this is knowing the structure of a quadratic function, and then also the shape of this type of graph compared to a linear or exponential. All right, so what I want you to do is I want you to pause the video and try the your turn problems now. And then when you're done, hit play, and you can see how you did. All right, good job and good luck. Bye-bye. All right, so for this activity, you had to label each representation as either linear, exponential, or quadratic. Okay, so let's first take a look at the graphs. These are the easiest ones to do. So we know this first one makes a line, so we know that's going to be linear. And this one over here, well, this has that growth, right? So this is going to be exponential. And then this one over here, that's our one graph that's a quadratic. Because again, it makes that U like a parabola, and that's going to be our quadratic function. All right, now let's take a look at the equations. This one here has that the form of an exponential. So this is going to be the e for exponential. This one here has the form y equals mx plus b. So this is going to be linear. But notice these two. These two has the squared, right? And again, that's a sign that it's going to be quadratic. So q and q. And finally, we have an input-output table. So we have x is 2, y is 4, x is 3, y is 9, x is -2, y is 4, and x is -3, and y is 9. So if you notice, to go from the x to the y, we're squaring this, right? So this would be the function y equals x squared. And again, we have a squared, which makes this a quadratic function. All right, how'd you do?